Robots are not as far away from us as you may think. There are already quite a few types of robots in our everyday life. From house cleaning robots to musical robots, and even self-driving cars. However, some creative engineers have taken things to the next level by combining the sophistication of technology with the natural beauty of animals to create some of the most amazing creations around. Here are the 10 most amazing robots that will make you fall in love. Ilium. The Ilium is a strange-looking, autonomous underwater vehicle that takes the shape of a snake. The Ilium concept will save the operator time and money, reduce the risk to workers, and cut carbon emissions by a lot. This is because the robot is designed to stay on the seabed permanently and travel long distances to do tasks that would normally be done by an ROV sent from a surface vessel to an oil field. During normal operations, a single Ilium robot has the potential to cover an area of around 20 square nautical miles with its service footprint. The body is made to go into a hibernation mode when it is not being used. This makes it flexible enough to fit into small spaces while keeping a slim profile. Bionic Flying Fox. Within specified airspace, the Bionic Flying Fox can operate in a semi-autonomous manner by communicating with a motion tracking system. The installation maintains a constant awareness of its position. While doing so, the system lays out the paths and gives essential control commands. Takeoff and landing are both manual processes that are carried out by the human pilot. During the flight, the control is transferred to autopilot. An essential element of the motion tracking system is comprised of 2 infrared cameras that are mounted on a pan and tilt mechanism. They can be twisted and tilted thanks to this feature, which enables them to track the full flight of the Bionic Flying Fox from the ground below. Bionic Wheelbot. The robot was based on the flick-flack spider, which is native to Morocco. The tripod gait allows the Bionic Wheelbot to move forward. The artificial spider needs only 6 of its 8 legs to walk, folding up the 2 legs that are referred to as the push-off legs. For every step, 3 legs will remain planted firmly on the ground, while the other 3 will be lifted, propelled ahead, and then set back down on the ground. The same technique is then used to move the other 3 legs that were just on the ground ahead. The drives must exert rather significant forces for the artificial spider to be able to move its long legs rapidly and effectively. To accomplish this, they are supported by a spring mechanism. Crabster CR200. Researchers from the Korean Institute of Ocean Science and Technology are the ones responsible for developing the Crabster CR200. The mission of this robot is to investigate the structure of the seabed, as well as any shipwrecks that may be present. The CR200 features 6 legs for making mechanical contact with the seabed, and just like its biological relatives, the 2 front legs can also function as robotic arms for manipulating objects underwater. It can pick up objects and store them in a chamber located on the front of the device. Because the bot has 10 optical cameras and a long-range scanning sonar that can scan up to 200 meters away, it can do the same inspection and manipulation in an area with low visibility. Bionicans. Bionicans work together under clear rules. They can interact with one another and coordinate not only their behaviors but also their motions. Each ant makes its own decisions independently, but in doing so, it is always submissive to the common aim, and as a result, it contributes in some manner to the overall effort to solve the problem. The artificial ants move an object across a specified region by working together to apply combined forces of pushing and pulling. They can move loads that would be too heavy for a single ant to carry, because they have figured out how to divide up the work. Manta Droid. The Manta Droid is a manta-inspired robot that was designed by researchers at the National University of Singapore. It moves through the water by flapping two flexible wings and allowing fluid dynamics to take care of the rest of the process. Because the machine has only a single electrical motor powering each wing, it is both efficient and attractive to look at. This is one of the bot's many selling points. The length of the robot is just around 14 inches, and its width is about 2 feet. In addition to this, it is lightweight, with the basic body weighing in at a mere 1.5 pounds. It travels at a speed of approximately 1.6 miles per hour, which is equivalent to twice its body length. Bionic Kangaroo. This can realistically mimic how real kangaroos jump, which means that they can use the energy they get from one hop to help them get ready for the next one. It utilizes a real elastic spring that, upon landing, charges the legs to some extent. Even though the entire robotic animal only weighs 7 kilos and stands a meter tall, it has a vertical jumping distance of 0.4 meters and a horizontal jumping distance of 0.8 meters, which is quite astounding. Naturally, an internal power source is also required, and the Bionic Kangaroo makes use of either a small compressor or a storage tank to supply high-pressure air to the pneumatic muscles that power the jumping motion. Everything on the robot is powered by lightweight batteries, and it has a complex kinematic control system to protect it from falling over. Velox. The Velox was designed by a company in Brooklyn known as Pliant Energy Systems, and it is capable of swimming, skating, slithering, and crawling through the water, as well as across a variety of different types of terrain. The key is a wavy propulsion system that can be changed in real time to adapt to different environmental conditions. Only one set of fins is required for the Velox to move about to mimic the many ways of mobility present in the animal kingdom. These fins allow the robot to swim like a ray, crawl like a millipede, jet like a squid, and slither like a snake. They are best described as hyperbolic, four-dimensional objects. As an underwater vehicle, the robot's ability to quickly change directions and make quick turns makes it perfect for tasks like inspecting coral reefs or chasing dragonfish, which require a craft that can move quickly so it can look around and between different things. Robird T8X. The T8X is the only robot available on the market that combines such a high level of likeness to a genuine spider with delicate movements, programmability, and the ability to be customized. It is also realistic in both appearance and behavior. The robot is equipped with 26 servo motors and is powered by the Bigfoot robotics engine, which contains advanced robotics algorithms for controlling multi-legged walking robots. As a result, the robot is capable of making a wide variety of bio-inspired and realistic movements, and the possibilities are virtually endless. You only need to provide the robot with simple commands on your smartphone, tablet, or computer. Inverse kinematics calculations, leg trajectory planning, leg gait coordination, motor control, and several other functions are all part of these computations. Robird. The Robird is a robotic drone that can move through the air by flapping its wings. For the most part, it is put to use at airports, landfills, ports, and the agricultural sector to lessen the burden that birds put on these areas. The wings of Robird can flap. It has high-impact flights lasting 5 minutes each, similar to those of a falcon. The bird can go up to 43 kilometers per hour, just like the birds that inspired it. There you have it. Let us know in the comments which animal robot you find the most amazing.